All right, let's get into it. We're diving into what is, without a doubt, the most critical phase of any AI project: model development. This is where the magic really happens, where an abstract idea and a whole lot of data get turned into a real working AI. So think about it. You've done all the prep, you've got a killer business case, your data is squeaky clean. So what's next? How do you actually take that raw material and build the intelligent engine that's going to power the whole thing? Well, this is it. This is the moment where all that groundwork finally pays off. We're now in the phase where raw data gets transformed into a functioning AI model that can actually solve problems. Let's see how it's done. First things first, let's talk about the AI build phase. The best way to think about this is like a bridge. It's the thing that connects your blueprint, your business goals and all that data, to the actual final structure, a real AI system that can start delivering some serious value. And boom. Right at the start, you are faced with what might be the single most important decision of the entire project. It's a fork in the road, and the path you choose, whether to build, buy, or integrate, is going to define pretty much everything that follows. So what's the deal here? Well, it really boils down to a classic trade-off. On one side, you can build a custom model from the ground up. The huge advantage? You get total control, and you create something that's uniquely yours, a real competitive edge. But it's going to take a lot of time and some serious expertise. On the other side, you can grab a pre-trained model off the shelf. This is way, way faster and lets you tap into world-class technology right away. The work just shifts to making sure you pick the right one and integrate it perfectly. So when does it make sense to go all in and build from scratch? You take this path when your data has these really unique patterns that nobody else's does, or when owning the AI itself is your secret sauce, your strategic advantage. Sometimes strict compliance rules mean you just have to have absolute control. That's another reason to build. Okay, so what about the other side of the coin? When do you buy or integrate? Well, you do this when your problem is a pretty common one, like, say, recognizing images and photos. And you do it when speed is absolutely everything. It's also the smart move if your team doesn't have deep AI research chops, and your main goal is just to get access to a powerful capability, not necessarily to invent a new one. Now, here's something you've got to keep in mind. Not all AI fields are created equal. For common tasks like computer vision or building a chatbot, the ecosystem is huge. You've got tons of options, from cloud services to open source models. But for something super specialized and safety critical, like an autonomous vehicle, yeah, a custom build is pretty much your only option. And that brings us to the absolute game changer in this space: generative AI. The heart of Gen AI is something called a foundation model. Just think of it as a massive, pre-educated brain, like a large language model, an LLM, that's already been trained on a huge chunk of the internet and can now be adapted to do all sorts of different things. And what this means for you is, well, it's huge. It means you can suddenly spin up models for really complex tasks, like building amazing conversational AI or creating original content, stuff that just a little while ago would have been a massive, multi-year project to build from scratch. Okay, so you've picked your path. You've made that big strategic choice. Now, the real work begins. Let's walk through what the execution actually looks like for each of these three distinct paths to getting a working model. If you're building custom, you're in for a serious engineering challenge. It all starts with setting up secure training environments and building pipelines that you can run over and over again. Then comes the really meticulous part: tuning what are called hyperparameters. Think of these as all the little knobs and dials inside the model. And all the while, you're constantly validating, making sure the model is actually learning patterns, not just memorizing the data you fed it. Now, if you're adapting a pre-trained model, your job looks totally different. It's much less about building from scratch and more about being a smart modifier. A really common technique is to freeze the early layers of the model, the parts that learned general things about the world, and then you only retrain the final layers on your specific data. It's kind of like teaching a world-class doctor a new specialty, not teaching them medicine from square one. And then there's the Gen AI workflow, which is a whole other ballgame. Here, it's all about guidance and control. You're engineering prompts, you're putting in systems like RAG, that's a fancy term, retrieval augmented generation, but it just means you let the model look up answers in your own private trusted documents. And you're building super strict quality controls to make sure the output is accurate and sounds like your brand. So you've got a model. It's trained, it's running. We're done, right? Not so fast. Here's the critical part. A model is only truly ready when you can prove that it works and that it actually aligns with the business goals you had from the very beginning. Think of this checklist as the final exam before deployment, and it goes way beyond just checking for accuracy. We're asking bigger questions now. Are the results statistically real, or did we just get lucky? Can the model handle the messy, weird data it's going to see in the real world? And, the two most important questions. Does it actually move the needle on a key business metric? And do the people who actually have to use this thing agree that it works? But even if a model aces every single one of those checks, there's one more layer. And honestly, it might be the most important one of all. Because a technically brilliant model can be completely useless, or even worse, dangerous if people don't trust it. And this quote right here just nails it. The real goal isn't just to build a model that's powerful. It's to build one that is ethical, that we can explain, that's secure, and that respects user privacy. So how do you actually build trust? It's not just wishful thinking. This abstract idea breaks down into real, concrete actions. It means you're constantly checking for and fixing bias. It means you build tools so you can understand why the model made a certain decision. It means using fancy techniques to protect user privacy and trying to break your own model to make it more secure against attacks. And this really is the key takeaway here. Trust is not a feature you can just bolt on at the end of the project. It has to be woven into every single decision, every line of code, right from the very beginning. So here we are. You've done it. The model is built, it's validated, it's trustworthy, it's ready to go out into the real world. But in a world where data is always shifting, where customer behavior changes, where the business itself is constantly evolving, is the work ever really done?